Regression testing is a type of software testing that ensures that recent code changes have not adversely affected the existing functionality of the application. Its primary goal is to confirm that new features, updates, bug fixes, or enhancements do not introduce new defects into previously tested and stable areas of the software. Key aspects of regression testing. Objective: to validate that recent changes or additions have not broken existing features and that the application continues to function as expected. Scope: involves retesting the unchanged parts of the application alongside the modified areas to ensure overall system stability. Focus: ensures that old bugs do not resurface and new changes do not introduce additional errors. When to perform regression testing. After code changes, such as bug fixes, enhancements, or optimizations. Following updates to dependencies, libraries, or frameworks that the application relies on. During integration of new features or modules to ensure compatibility. As part of the CI/CD pipeline to continuously validate that changes do not break existing functionality. Types of regression testing. Corrective regression testing, used when there are no changes in the existing code. Tests are reused as is to validate that everything still works. Progressive regression testing, applied when new changes or functionalities are introduced, requiring the modification or addition of new test cases to cover the changes. Selective regression testing, focuses on retesting only the modules or components impacted by recent code changes rather than the entire application. Partial regression testing, conducted to verify that changes in a specific module do not affect the functionality of other related modules. Complete regression testing, involves testing the entire application, often performed when significant code changes or multiple changes are made. Unit regression testing, involves testing a specific code unit in isolation, often conducted by developers before integration. Steps in regression testing. Identify test cases, select test cases that cover the modified code paths, existing functionalities, and any critical workflows. Test case prioritization. Prioritize test cases based on the criticality of features, code complexity, and the impact of recent changes. Test environment setup. Prepare an environment that mirrors production closely to get realistic test results. Execute test cases. Run the selected regression test cases, monitoring for failures or deviations from expected outcomes. Analyze results. Review the results to determine if any issues have been introduced by recent changes. Defect reporting. Document any bugs or unexpected behavior and report them to the development team for resolution. Rerun tests. Once defects are fixed, re-execute regression tests to ensure stability. Tools for regression testing. Selenium automates browser-based regression tests, supporting multiple languages like Java, Python, and C#. JUnit/TestNG, Java-based frameworks for unit and regression testing, commonly integrated into CI/CD pipelines. PyTest, a Python-based framework that supports unit, integration, and regression tests with extensive plugin support. Cypress, modern front-end testing tool suitable for automating web application regression tests. Catalan Studio, an all-in-one automation tool that supports web, mobile, API, and desktop testing, ideal for regression test automation. Jenkins, used for continuous integration, Jenkins can automate regression testing as part of the CI/CD pipeline. Best practices for regression testing. Automate repetitive tests. Automate frequently executed regression tests to save time and reduce human error. Maintain regression test suites. Regularly update regression test cases to reflect changes in the application and retire obsolete ones. Prioritize critical test cases. Focus on high-impact areas, critical paths, and features that are most likely to be affected by changes. Use CI/CD integration. Integrate regression tests into the CI/CD pipeline to continuously validate code changes. Keep test data consistent. Use controlled and consistent test data to ensure reliable and reproducible results. Version control. Keep track of test scripts and results using version control to maintain a history of changes and test coverage. Monitor and report. Continuously monitor test results and report any failures promptly to the development team. Example of regression testing using Selenium and Python. Below is a simple Selenium script in Python that demonstrates regression testing for a login functionality. #test_regression_login.py. From Selenium import WebDriver. From selenium.webdriver.com and .by import by. Import ptest. Add ptest.fixture. Def setup. Driver equals webdriver.chrome. Make sure to specify the correct path for the Chrome driver. Driver.get. https://example.com. Replace with the actual application URL. Yield driver. Driver.quit. Def test_valid_login. Setup. Driver equals setup. #locate and interact with the login fields. Driver.find_element. by.id. Username. .send_keys. valid_user. Driver.find_element. by.id. Password. .send_keys. valid_password. Driver.find_element. by.id. Login button. Click. #verify successful login by checking for a known element on the dashboard. Assert dashboard in driver.title. Def test_invalid_login. Setup. Driver equals setup. #attempt login with invalid credentials. Driver.find_element. by.id. Username. .send_keys. invalid_user. Driver.find_element. by.id. Password. .send_keys. invalid_password. Driver.find_element. by.id. Login button. Click. #verify that the error message is displayed. Error_message equals driver.find_element. by .class_name. Error message. Assert error_message. is displayed. Assert invalid credentials in error_message.text. Def test_logout. Setup. Driver equals setup. #simulate a login to perform logout test. Driver.find_element. by.id. Username. .send_keys. valid_user. Driver.find_element. by.id. Password. .send_keys. valid_password. Driver.find_element. by.id. Login button. Click. #click the logout button. Driver.find_element. by.id. Logout button. Click. #verify successful logout by checking the URL or page title. Assert login in driver.title. Explanation. Setup fixture sets up the WebDriver session and navigates to the application URL before each test. Valid login test verifies that a user can log in with valid credentials and reach the dashboard. Invalid login test tests that an error message appears when login fails due to incorrect credentials. Logout test simulates a login and then logs the user out, checking for correct redirection to the login page. This approach allows you to ensure that critical user flows remain functional after each change to the application.